Hi friends, welcome to CSE PEDIA. Today we are going to discuss about finite automata with output. So till now we constructed deterministic finite automata, non-deterministic finite automata. Now we need to construct a finite automata with output. So what if we have an output for a finite automata? Here to do this we will discuss about two machines. The first one is Mealy Machine, the second one is Mealy Machine. The first one is Mealy Machine and the second one is Mealy Machine. So what is Mealy Machine? So discussing about Mealy Machine. So Mealy Machine is a 6 tuple. So what is this 6 tuple basically? Q0. So these are your 6 tuple. So Q is a finite set of states. Sigma is finite set of input symbols. Delta output alphabet. And this delta is transition function. This lambda is an output function for Q tends to delta, and as we know this delta is a transition function, so Q into that tends to Q. This is known as a state function. Okay, so and Q0 is your initial state. So this is a 6 tuple. As we know, deterministic finite automata or non-deterministic finite automata is a 5 tuple thing, but coming to Mealy Machine or Mealy Machine or finite automata with output, it's a 6 tuple one. Now we will see an example for Mealy Machine. Mealy Machine. So what is the structure of a Mealy Machine? So Mealy Machine looks like this. This is start, Q0, which is associated with output. So this is input, Q1, which is associated with output, which is Q2, which is associated with output, so this is a given Mealy Machine. So for each state we have an output. So the output for Q0 is 1, the output for Q1 is 1, the output for Q2 is 0. Here the current states are Q0, Q1 and Q2. So what are the next states? So next state depends upon the input 0 and 1. So what are the input alphabet here? 0 and 1. So next state depends upon the input alphabet 0 and 1. And what is the output? So output is clear here. For Q0 the output is 1, for Q1 the output is 1, for Q2 the output is 0. So now let us construct a table for this. The transition table will look like this. My current state, next state, delta. So here my inputs are 0 and 1, and next one is output. So output is lambda. So how many states do I have here? Q0, Q1 and Q2. Okay, so Q0 on 0. So Q0 on 0 we are going to Q1. So Q0 on 1 we are going to Q2, and the output associated with Q0 is 1. So Q1 on 0 we are going to Q2. So Q1 on 1 we are going to Q1. The output associated on Q1 is 1. So Q2 on 0 we are going to Q2. So Q2 on 1 we are going to Q0. The output associated is 0. So in this way we can construct a transition table for Mealy Machine. So what is the exact difference between Mealy Machine and Mealy Machine? So in Mealy Machine, output is associated with the current state itself, and the input is separately given. So coming to Mealy Machine, even Mealy Machine is a 6 tuple one, but the difference is the output and input will be at the same place. So in Mealy Machine, as we are saying, that the output is associated with the state, but in Mealy Machine, the input and output will be given as an input. Okay, so let's see what a Mealy Machine is. Okay, so coming to Mealy Machine, even Mealy Machine is a 6-tuple one. So if you see the diagram here, in the previous diagram for Mealy Machine, the output is associated with the state, but in Mealy Machine we have current states Q0, Q1 and Q2, and the input and output are at the same place. So here the 1 is an input and 0 is an output. Here 0 is an input and 0 is an output. This 1 is an input and 1 is an output. 0 is an input, 0 is an output. This 0 is an input, 1 is an output. This 1 is an input, 0 is an output. So in this way we will construct a Mealy Machine. So the transition table is entirely different from Mealy Machine. Okay, so we'll see some examples of Mealy Machines and Mealy Machine. Later on we have conversions from Mealy to Mealy and Mealy to Mealy. So Mealy Machine and Mealy Machine are two important concepts. So let us discuss an example on Mealy Machine. So the question is, this is an important question. Design a Mealy Machine to generate ones complement of a given binary number. So to generate ones complement of given binary number, so first we need to think about the logic. So what is ones complement here? If your input is 0, then your output should be 1. Why? Because complement of 0 is 1. If your input is 1, then your output should be 0. Why? Because complement of 1 is 0. See, the output is very simple, the logic is very simple here. So let us construct a Mealy Machine. So I should have 3 states here. So one state for start state, second state is for taking zeros as input and produces an output 1, and third state is for taking ones as an input and producing output as 0. So let us take 3 states here, Q0, Q1 and Q2. So let us start here. So this is a start state. So this is Q0. So initially my output is 0. Okay. Why? Because it starts from 0. Next, one input is for 0. That means if we give 0, we should get 1. If the other input is 1, if we give 1, the output should be 0, right? So take another state Q1. So what input we took here? 0. So if you take 0, the output should be 1. So in Mealy Machine, as I already discussed, the output will be present in the state itself. So the input is 0, the complement of 0 is 1. So the output is 1, right? So the output is 1. I should take a self loop. So what I will get here? Input. Why? Because the output is 1, obviously the input should be 0. Next, take another state Q2. Here my input is 1, so output should be 0, opposite to this complement. So my output is 0, the self loop should be 1. Okay, so here my output is 1, so from here I should get input 0. Here the output is 0, so I should get input 1. So in this way we construct a Mealy Machine. So if you see, the logic is correct. Now let us take a binary number 1011 and check whether it's working or not. So my binary number is 1011. This is the input, state, output. Okay, so my input is 1, 0, 1, 1. Okay, so my initial state is Q0, right? So Q0 on 1, where I am going? Q2. So Q2 on 0, where I am going Q1. So Q1 on 1, where I am going Q2. So Q2 on 1, where I am going Q2 itself, right? So Q0 on 1, so the output for Q0 is 0, so 0. The output for Q2 is 0. The output for Q1 is 1. The output for Q2 is 0. The output for Q2 is 0. So what answer we got here? 0, 0, 1, 0, 0. So what is my number? 1, 0, 1, 1. So what I should get here? 0, 1, 0, 0. So this is my number. So I got 0, 1, 0, 0. So in this way, I should generate a Mealy machine such a way that it should work for one's complement of a given binary number. So you can take any number and check the output for this. Now we should construct a truth table for this. Why? Because as we know that we have three outputs here. The first output is 0, the second output is 1, and the third output is 0. Now I should show my transition table in such a way that it covers the current state and next state along with output. So what is my table here? So this is my current state. This is my next state, and my inputs are 0, 1, and this is output. So this is lambda, right? So what is my current state here? Q0, Q1 and Q2. I have three states, so I am starting from Q0. So this is 0, 1. So Q0 on 0, I am going to Q1. So Q0 on 1, I am going to Q2. So what is the output associated with Q0? 0. Next, Q1 on 0, I am going to Q1. Q1 on 1, I am going to Q2. So what is the output associated with Q1? 1. Next, Q2 on 0, I am going to Q1. So Q2 on 1, I am going to Q2. So Q2 output associated is 0. So in this way, I generated my transition table for the given Mealy machine. So this is all about Mealy machine. So we'll see another example for Mealy machine. Now we'll see an example for Mealy machine as well. So design a Mealy machine to find 2's complement of a given binary number. So what is 2's complement? Let us take an example here. If I have 1, 0, 1, 0, what I should do? First find out the 1's complement for this. Later on add 1 to this. So 1's complement of 1, 0, 1, 0 is 0, 1, 0, 1. Why? Because I am making 1 as 0 and 0 as 1 and adding 1 to the LSB. So 0 with carry 1, 1, 1, 0. I got 0, 1, 1, 0. So the logic behind this is very simple. For designing 2's complement of a binary number, we assume that input is read from LSB to MSB. So input is read from LSB to MSB, and we'll keep the binary number as it is until we read the first one. So from LSB to MSB, we should read the first one. So up to then, you should keep the binary number as it is. Keep that one as it is. So when we encounter with the first one from LSB to MSB, we should keep that one as it is and convert the remaining ones as zeros and zeros as ones. Now we'll get the final 2's complement of that binary number. I hope you understood. So let's take an example here. So let's take 1, 0, 1, 1. So this is MSB. This is LSB, right? So coming from LSB to MSB, I encountered first 1. So what I should do? If we encounter first one from LSB to MSB, keep that one as it is. So I am keeping that one as it is and change ones as zeros and zeros as ones. So this 1 will be converted as 0 and this 0 will be converted as 1 and this 1 will be converted as 0. So what is my final answer here? 0 1 0 1. Let's check whether it works or not. So what is the given what's the number we took here? 1 0 1 1. So in order to find the 2's complement for this, first we should find out 1's complement. So what is 1's complement here? 0 1 0 0. Next what we should do? We should add 1 to this. So adding 1 to this, 1 0 1 0. So 0 1 0 1. So this is the number which I got for our procedure. So the procedure is very simple here. What we should do? We should check whether we encounter with a first one starting from LSB to MSB. If we encounter with first one, keep that one as it is and change remaining ones as zeros and zeros as ones. So in example which we took, LSB we have a 1, right? So let's take another number here. So that number is 1 0 1 0. Let us assume 1 0 1 0. So this is MSB and this is LSB. So starting from LSB to MSB, so the first encountered is 0. So forget about that. So what is the next encountered? 1. So keep this 1 as it is. So 0 should be kept as it is and 1 is kept as it is. So the remaining 0 is converted to 1 and the 1 is converted to 0. So 1 0 1 0 we got 0 1 1 0. Let's check whether it works or not. 1 0 1 0, 1's complement is 0 1 0 1 and adding 1 to that, 0 with carry 1 1 1 0. So we got 0 1 1 0. You understood, right? So starting from LSB to MSB, if we encounter with 0, keep that 0 as it is. So we should check whether we got first one or not. So first one in the sense the one should be in, one should need not be in LSB. So first in our LSB we got 0. So keep that 0 as it is and go to the next one. So we got 1 over there. So keep that 1 as it is and we converted remaining zeros as ones and remaining ones as 0. So finally we got 0 1 1 0. So I hope you understood the concept here. Now we should construct a Mealy machine for this. So in Mealy machine, what I said, the output will be associated with the current state itself, but it is entirely different with the Mealy machine. The case is entirely different. In Mealy machine, we have states Q0, Q1 and Q2, but input and output will be at the same place. So now let's construct a Mealy machine for this. So the Mealy machine is very simple here. So I have only 2 states. So let us assume that this is the state Q0. Okay. So Q0, and what if we encounter any 0? If my input is 0, what I need to do? I need to keep that 0 as it is. Why? Because we need to check for 1 starting from LSB to MSB. So what if I have an input 0? Keep that as it is. So my output will also be 0. Why? Because I have not changed anything. So my input is 0 and output is 0. Next, what if I got 1? So the first 1 is encountered. So my input is 1. The first 1 is encountered. So what we said, if we encounter with the first one, keep that 1 as it is. So my output will also be 1. Why? Because we should not change that 1. Next, go to state Q2. The first 1 is encountered. We should keep that 1 as it is. So what is the next case? If we have any zeros, convert that to ones. If we have any ones, convert that to zeros. What if I get an input 0? You should convert that to 1. So my output will be 1. What if I get an input 1? Convert that to 0. So my output will be 0. So this is a Mealy machine. So the matter is very clear. We should go from LSB to MSB and we should check the first one is encountered or not. Whenever the first one is encountered, we should not change that one, and the remaining zeros are converted to ones and remaining ones are converted to zeros. So this is the exact difference between a Mealy machine and a Mealy machine. Let's solve different examples on these Mealy and Mealy machines. Later on we'll go for conversion of Mealy to Mealy and Mealy to Mealy. So if you like my videos, please subscribe to my channel and please share my videos to your friends. Thank you.